Hello, in this problem we're going to prove that n cubed plus 2n is divisible by 3 for all integers n greater than or equal to 0. Let's go ahead and go through the proof. Now, before we go through the proof, which we're going to prove via induction, let me just briefly refresh your memory on what this means. So we say that A divides B, or in other words, B is divisible by A. This is the same thing as saying that B is a multiple of A. So B is equal to some integer, say M, times A. So for some integer M. So A divides B means B is a multiple of A, or B is divisible by A means that B is a multiple of A. So that's how we're going to think about it as we go through it. Okay, in induction proofs, I always like to start with the base case, and I tend to write my steps. So base case. So our statement that we're trying to prove is this one right here. We want to show that n cubed plus 2n is divisible by 3. So you could give this a name if you wanted. You can call it like P sub n or S sub n. It doesn't really matter. You don't have to give it a name. I'll just make up a name just for clarity. So S sub n, if you want to give it a name, we'll call it that. And we want to prove that S sub n is true for all integers n greater than or equal to 0. So in the base case, you have to start by showing it's true for the smallest positive integer in question. In this case, that's n equals 0. So we have to look at this statement when n equals 0. So let's look at the case when n equals 0. That's the base case. In this case, we have 0 cubed plus 2 times 0. But that's equal to 0. So is that divisible by 3? In other words, is it a multiple of 3? Well, yeah, it sure is. It's equal to 0 times 3. And you see how it matches here, the formula. Your m here is 0 and your a is 3, right? Because it's divisible by 3. So S sub 0 is true. The statement is true for the very first positive integer, which is 0. In the next step, we're going to assume that our statement is true for some integer k greater than or equal to 0. This is called the induction hypothesis. Okay, induction hypothesis. So in this step, all we do is assume that this is true for some k. So I'll say, suppose that k cubed plus 2k is divisible by 3 for some, not positive, it's not positive because we're allowing 0, for some, let me just say integer, you get used to saying positive, integer k greater than or equal to 0. So that's called the induction hypothesis. Okay. The next step is called the induction step. So induction step. A lot of people don't write the steps, and a lot of people combine the last two steps. I really like to separate them because I think the induction hypothesis is very important, and it's really important to recognize when you use it. You have to use it, okay? So that's key in all induction proofs, when you use the induction hypothesis. So in the induction step, we have to show our statement is true when n equals k plus 1. So claim that k plus 1 cubed plus 2 times k plus 1 is divisible by 3. Divisible by 3. And basically, I'm just plugging in k plus 1 here because I can't see the original problem. I have not done this problem before. So here, we're basically plugging in k plus 1 here. So k plus 1 cubed, and then 2 times k plus 1. All right, so now we just have to show that this is divisible by 3, and we're done, basically. So I'm going to switch colors here because this is the hardest part of the problem. So we'll start by writing this down, and basically we have to show that it's a multiple of 3. That's why I kept saying it earlier. It's a good way to think about it. So then k plus 1 cubed plus 2 times k plus 1. So we somehow have to use this, right? So the natural thing to do is to multiply this out. So k plus 1 cubed, I have this memorized. It's k cubed plus 3k squared plus 3k plus 1. It's just something from memory. It's worth memorizing. You can memorize it from Pascal's triangle. 1, 1, 1, 1, 2, 1. You add, 1, 1. So it's 1, 3, 3, 1, 1, 3, 3, 1. And then the powers decrease. So eventually you'll memorize it. Plus 2 times k is 2k. Plus 2 times 1 is 2. Okay, so now we know something about k cubed plus 2k. We know it's divisible by 3. So that means it's a multiple of 3. So let's look down here and see if we can do something with that. So let's see. I'm going to switch colors here. I'm going to go to yellow. So here's k cubed. And then here's 2k. So let's take those out. Let's extract those from all of this and separate them and write them here, because we know that this is a multiple of 3. And now let's combine what's left over and cross our fingers. So this is plus 3k squared plus 3k. And then plus 1 plus 2 is 3. Oh, beautiful. Look at that. That's really, really cool. So this is going to be equal to 3m. And that's for some integer m greater than or equal to 0. This step here is by IH. This is by the induction hypothesis. I'd like to emphasize where in the proof I'm using the induction hypothesis. If you're doing this for like a class, like maybe you're in school, then you probably want to do that. It just makes it way cleaner. So that's where we're using the induction hypothesis. And here, look at this, we can pull out a 3. So this is k squared plus k plus 1. I want to emphasize why, right? It's because k cubed plus 2k is divisible by 3. In other words, it's a multiple of 3, so we can write it as 3 times m for some integer m greater than or equal to 0. And now we can pull out a 3 here. So this is 3 m plus k squared plus k plus 1. And where this is an integer, so m plus k squared plus k plus 1 is an element in the set of integers. I know I'm introducing some new notation. This means is in, belongs to, and this z stands for the set of integers. The reason they use the letter z is because there's a German word. I don't know how to say it. It's Zahlen or something like that. And I think it means numbers. So it's named after something in the German language. Pretty cool. In any case, this is equal to 3 times an integer. So this is a multiple of 3. So this is divisible by 3. So we have that k plus 1 cubed plus 2 times k plus 1 is divisible by 3. This shows that our statement is true when n is equal to k plus 1. So this shows that s sub k plus 1 is true. You might say, what is s sub k plus 1? S sub k plus 1 is our statement when n is equal to k plus 1. Right here, that's our statement when n is n. Here we're looking at s sub 0. In the induction hypothesis, we basically assume s sub k is true. I didn't write that explicitly, I just actually wrote s sub k right here, right? That's what it is here. This underlined piece in orange is s sub k. So suppose s sub k, which is k cubed plus 2k is divisible by 3, is true for some integer k, and then we show it's true for k plus 1. So because we've shown the base case, and we've shown that if our statement is true for n equals k, it's also true for k plus 1. When you combine those two things, we can invoke the principle of mathematical induction and say that our statement is true for all integers n greater than or equal to 0. So thus, by the principle of mathematical induction, so mathematical induction our statement is true for all positive integers n. So S sub n is true. Well, not for all integers n greater than or equal to 0. So we have that 3n, make sure I write it down right. Not 3, n cubed plus 2n. 3's are stuck in my head. N cubed plus 2n is divisible by 3 for all integers n greater than or equal to 0. And that completes the proof, so I'll put a little box there. So that's a full induction proof. So if you're doing this for fun or whatever, this would be a correct way to do it. So again, the labeling of the steps I think really helps. So, and the key thing in this problem is really to just understand what this means. N cubed plus 2n is divisible by 3 means that it's a multiple of 3. So you show the base case. And again, when you're showing the base case, you show it's true for the smallest integer in question. In this case, it was 0. In the induction hypothesis, you assume that your statement is true for some k greater than or equal to 0. In the induction step, you show it's true for k plus 1. And we did that here. Here's where we used the induction hypothesis because we know this is a multiple of 3 by the induction hypothesis because this is divisible by 3. And then here we just use some algebra. Factor out of 3, just mention that this is an integer. It's 3 times an integer. So this whole thing is equal to 3 times an integer. So this whole thing is a multiple of 3. Therefore, that means it's divisible by 3. And because we've showed that the statement is true for k plus 1, it shows that S sub k plus 1 is true. And so we've done two things. We've shown that it's true for the base case, and we've shown that if it's true for k, it's also true for k plus 1. Those two things combined allow us to invoke the principle of mathematical induction and say that our statement is true for every positive integer, every integer n greater than or equal to 0, right? Because we have to include 0. You got to be careful. I hope this video has been helpful to someone out there in the world who is trying to learn some induction. Good luck.